a journey of 70 years to reach the edge of a black hole. This isn't a line from a movie. It's a serious proposal from astrophysicist Cosimo Bambi, published in the peer-reviewed journal iScience. He suggests that within our lifetime, we could launch a probe, no heavier than a paperclip, on a century-long mission to test the very limits of physics. The idea lands at a pivotal moment. For a century, Einstein's theory of general relativity has been our guide to the cosmos, passing every test we've thrown at it. In 2015, the LIGO and Virgo observatories first detected gravitational waves from merging black holes, a discovery that opened a new way to sense the universe. Just a few years later, the Event Horizon Telescope gave us our first direct image of a black hole's shadow. But these amazing tools are still observing from afar. Bambi's proposal argues that to truly understand the extreme gravity at a black hole's edge, where our theories might break down, we need to go there. The concept visualizes a tiny, gram-scale spacecraft pushed across the stars not by fuel, but by a powerful beam of light from Earth.
Today, we'll find out why scientists are so desperate to study a black hole up close. We'll look at the incredible technology required to send a tiny ship into interstellar space. And finally, we'll analyze what this mission could actually discover at the edge of reality. To understand why we'd travel for a century, we first need to appreciate the limits of our knowledge. General relativity works beautifully in our solar system, but black holes are the universe's stress test. They are the source of the strongest gravitational fields imaginable, an ideal laboratory for pushing Einstein's theories to their breaking point. So far, all our observations, from radio waves to gravitational ripples, confirmed the theory, but they are indirect. They are like trying to understand an engine by only listening to its sound. To really know how it works, you have to look under the hood. For physics, that means sending a probe.
But where exactly would we send it? The nearest confirmed black hole, Gaia BH1, is about 1,560 light-years away, far too distant for a practical mission. Most black holes are thought to be solitary wanderers, making them nearly invisible. We can only spot them through rare events, like when their immense gravity bends the light of a distant star behind them, an effect called gravitational microlensing. This makes finding a target the first great challenge of the mission. Cosimo Bambi's proposal hinges on discovering a much closer, yet unseen black hole, perhaps just 20 to 25 light-years away. He believes that with new detection techniques, we might find such an object within the next decade. The entire mission depends on having a destination that is reachable within a human lifespan, or at least a comprehensible time frame. The first step, therefore, isn't building a ship, it's completing the map of our own cosmic neighborhood. So, we need to get a probe to a nearby, currently invisible black hole to test if our fundamental understanding of gravity is correct. The proposed solution is a nanocraft, a tiny probe weighing only a gram or two, attached to an ultralight sail about 10 square meters in area. This is not a new idea. It's the core concept behind the Breakthrough Starshot initiative, which aims to send similar probes to our nearest star system, Alpha Centauri. The method of propulsion is where things get truly ambitious. A massive ground-based laser array would focus a powerful beam of light onto the nanocraft's sail. This constant pressure from photons would accelerate the tiny probe to incredible speeds. The goal is to reach 1/3 of the speed of light. At that velocity, a journey to a black hole 25 light-years away would take about 75 years. After arriving, the probe would need another 25 years to beam its findings back to Earth, making the total mission duration around 100 years.
Of course, the challenges are monumental. Building the required laser system today would cost an estimated 1 trillion euros. Bambi and other proponents suggest that within 20 to 30 years, technological advances could drastically reduce that cost, perhaps to around 1 billion euros, making it comparable to other major space missions. Beyond the cost, there are immense engineering hurdles.
The light sail material must be incredibly strong and light, able to withstand the intense laser blast without vaporizing. The craft would need to navigate through interstellar space with no way to change course after its initial push. And perhaps most difficult of all, it would have to transmit a clear signal back to Earth across trillions of miles.
If this mission could overcome these incredible obstacles, it wouldn't just be a technological marvel. It would be a revolution in fundamental physics. Sending a probe to the brink of a black hole would allow scientists to conduct 3 game-changing experiments. The first would be a direct test of the Kerr metric, which is the exact solution in general relativity that describes the geometry of spacetime around a rotating black hole. The second experiment would check if fundamental physical constants, like the fine structure constant, change in the presence of extreme gravity. And the third, most dramatic test would be to confirm the existence of the event horizon itself. One model for the mission involves the main craft releasing a smaller subprobe. Scientists could command this probe to fall toward the black hole. If its signal vanishes exactly as predicted, it would be the strongest proof yet of the point of no return.
So what does this all mean for us, right now and in the future? In the immediate term, a mission like this is not remotely possible. But the proposal itself is incredibly valuable. By publishing a detailed blueprint, Cosmo Bambi has sparked a debate and is pushing scientists and engineers to seriously consider the technologies needed for interstellar travel. It focuses research on key areas like laser propulsion, advanced materials for light sails, and the miniaturization of spacecraft components. These are technologies that will have applications far beyond this one-mission concept. In the near future, the real testbed for this idea will be the Breakthrough Starshot project. Their goal of sending a nanocraft to Alpha Centauri is a crucial first step. If they can successfully demonstrate laser-propelled interstellar flight over a distance of 4 light-years, it makes the far more ambitious journey to a black hole seem less like a fantasy and more like a future engineering project. The success or failure of Starshot over the next few decades will tell us a lot about the feasibility of Bambi's vision. Looking further ahead, if humanity develops the capability to send probes to nearby black holes, it fundamentally changes our place in the cosmos. It would mark the beginning of true interstellar exploration, allowing us to send robotic emissaries to other star systems to study exoplanets, stellar phenomena, and the interstellar medium directly. Such a mission would represent a multi-generational commitment to knowledge, a scientific endeavor passed down from one generation to the next. It could answer some of the deepest questions we have about the nature of reality and whether the laws of physics as we know them are truly universal. So, a 70-year journey for a paperclip-sized probe is far more than a speculative thought experiment. It is a potential roadmap, however challenging, for the future of astrophysics. Cosimo Bambi's proposal reminds us that some of the greatest leaps in science began with ideas that seemed, at first, completely unrealistic. Just as the detection of gravitational waves was once a distant dream, sending a messenger to the edge of a black hole could one day become a reality, allowing us to study the fundamental laws of nature in their most extreme form. While we wait for that technology, the search for the mission's first and most important component, a hitting black hole in our own backyard, is already underway.